I'm going to cover a topic kind of for, I guess, fun. I don't know if that's the right word. Kernel density estimation. Are you guys familiar with this already? No? Okay. Well, I'm going to cover it from a very high level perspective, okay? And so we've got kernel density estimation. It's going to be coming from a high level perspective. This will not be put on the final exam, okay? I will not put this on the final exam. Please don't just get up and leave now, though. Like a few students last class did that, and I was like, oh, that's a little messed up. But kernel density estimation, this is a tool that we use as statisticians in statistics quite often, and it is, I would classify it under computational statistics because it is a fairly computationally intense method. Okay, it uses a lot of our ability to create these density estimate curves rather quickly has only become possible because of the computer. All right, so I still classify this under a computational statistics thing, although it's a little bit different from some of the other computational methods that we've encountered. Okay, and we've already seen the usage of kernel density estimation when we were talking about some bootstrap estimates, and we were kind of creating these density plots at the end. Okay, and it's implemented in R using the function density. Okay, and this is kernel density estimation. Now, we are already familiar with a very basic form of density estimation, and that would be the histogram. Okay, so histogram is a very basic form of density estimation, and the idea behind a histogram is that it creates a visual display of what our data, the distribution of our data, right? So when you create I'm assuming you guys all know of histogram, and you've gathered data points, and you can put them along the number line, and they look something like this. All right, and as you kind of bin them together, and you say, oh, I've got 2 data points here, so we're gonna create a bin, that wide. Here's 1 data point right there, so it only goes there. I've got 3 data points in this region, so that bin goes right there. And this is a really terrible histogram, by the way. And maybe there's 2 in this one, so we'll go up to here or something like that. Okay, so here's some kind of histogram, right? And I'm imagining somewhere in your intro stats class you talked about describing shapes of distributions, and then they would take, here's this histogram, and we would do something like something like this, right? And we would say, oh, here's a kind of a estimate of our, the shape, right? Shape of the distribution. Okay. And at its very basic level, this is density estimation. We take our data and we plot it. We're creating a graphic display that gives us an idea of what the distribution looks like. Okay. And with kernel density estimation, we're effectively going to try to make these kind of smoothed out curves. Okay. So let me kind of flip our page. Lecture 2. Okay, so let's say you've collected data, all right, and or We got 1, 1, and negative 1. All right. And let's say we have 3 points in our sample, and they end up at 1, 0, and negative 1. And based on this, let's say we wanted to create some kind of density curve. Okay, we have a few options here. Okay, let me copy this for future. Okay, so one is, I could just create a histogram, and depending on how wide I want to make my bins, maybe it looks like this. Okay. So this is one possible histogram. It would look like that. Another possible histogram would have wider bins. And all 3 of these should be the same height here. And these kind of paint similar but slightly different pictures, right? Let me. Okay, so this is the kind of histograms with different bin width. Okay. And as far as kernel density estimation goes, we do something similar. Okay, with histograms, basically what we're doing is we're putting blocks wherever there is a dot. We see a dot and we put a block there, okay? And if there were 2 dots here, if there were 2 dots at this location, we would put a second block on top of it so that it would look, imagine that one being the same height as the other block, okay? And if there were 2 dots over here, we would do something like that, right? Here, let me just put them side by side. Okay, over here, let's say this is what we have. With kernel density estimation, rather than adding blocks per each dot, we're going to add curves together. So in a histogram, so let me just write this over here. With a histogram, we are essentially stacking blocks. Okay, so we're essentially stacking blocks for each data value we observe. Okay, and that's how we build a histogram. So with kernel density estimation, instead of stacking blocks, we stack curves, which are called kernels. Okay, we will quote stack curves that are called kernels. Okay, and oftentimes the default kernel that we use would be a Gaussian. So we'll say a Gaussian kernel. And the way a Gaussian kernel works is that at each dot, I have a normal Gaussian curve centered right at that dot there. Okay. So here I've got kind of this Gaussian curve right there. I'm going to have a Gaussian curve centered at this dot, another Gaussian curve centered at that dot, and here I have a Gaussian curved, I don't know how to draw, okay, Gaussian curve centered at that dot, okay? And so if I excuse me, if I take all of these curves and I add them together, what would the resulting thing look like? Okay, well, we would get kind of this this thing here, and then we would have this curve starting to add in and this curve starting to add in. So it would probably dip down a little bit, look something like this. Okay? Does that kind of visually make sense? What's going on there? So we're just kind of adding, we're just taking these things and we're adding them together to kind of get our thing. So this would be the what the resulting thing looks like. That's if our Gaussian kernel looks like that. Now, let me take this, Control C, and let me try a new page. What's going on here? Oh man, my keyboard is broken. Okay, I don't know what's going on. Something funny is going on. Okay, so we can also change the bandwidth. So over there I had curves that were kind of narrow. What if instead of using hang on, I'm sorry. My computer's acting funny. I'm gonna just stop the video here and reboot.